Good morning, students. Happy Wednesday. Today is April 29th. And in this video, I'm going to go over a new lesson with you. This is lesson part 2. And in this video, I go over how to do your discussion post. So please watch the entire video. You have to be getting your discussion questions answered correctly. So if the discussions have been difficult for you, I suggest you listen really carefully to this video and also take notes so that you can do better on your discussion posts. All right, so before we begin, just a reminder that yesterday's homework was to do your house design discussion number 1. I saw a lot of people write really great comments and I replied back to most of you, so go and check what I commented. And if you need to make corrections, you still can, and you can still get full points if you reply to my comments that I made. All right, so now again, we're going back to our purple folder because it's week 6, and today is Wednesday, April 29th. So here is your assignment for today. This discussion requires a password, so I will say the password. Make sure you listen carefully. Now, in this video, I go over everything you need to know for this discussion. So I even give in this video the correct answer to the discussion number 2. So no one should be getting it incorrect. Please prove to me that you watched and listened carefully to this video and get the discussion answer correct because I give you the correct answer. All right. So let's go to our class slides. This is week 6 again. Now we are going on to Wednesday. So let me fix this. We are on Wednesday, April 29th. And just a reminder, tomorrow is our video conference if you want to join us. All right, so we're ready for Wednesday's lesson. So our learning objective says, I will apply my understanding of thermal energy transfer to decide on the best size of the house that will help to minimize, slow down the rate of thermal energy transfer. And what will you do today? We're going to go over Tuesday's discussion question, and then you're going to watch this video and then comment on the discussion board. So today we're going to design the first part of our house. We're going to choose the size of the house that will help it minimize thermal energy transfer. So you're watching the video right now. It'll be posted on this slide if you need to see it again. Now, a quick review of yesterday's homework. I talked about how in the wintertime, the air outside is colder and the air inside is warmer. And I kept saying that thermal energy always goes from warm to cold. But many of you wrote that cold air will enter the house. Remember, cold air does not move. Coldness does not move. Only heat, thermal energy, is gonna go from the warm place to the cold place. So in the winter time, since it's cold outside, the hot air from the house will leave the house. Okay? And in the summertime, the outside is hot and the inside of the house is cold. So in this case, the hot air from the outside will enter the colder house in the inside. It always goes from hot to cold. Cold air does not move. So we talked about how we have to slow down or minimize the thermal energy transfer into and out of our houses without wasting energy. So yesterday's discussion asked you, in the wintertime, the air outside is colder and the air inside the house is warmer. How will thermal energy transfer in this case? Well, we just said the air inside the house is warm and the air outside is cold. So the air inside is higher temperature, the air outside is lower temperature. So if thermal energy always transfers from warm to cold, so thermal energy will have to go from the warm place to the cold place. So the arrow should look like this. And that means that in the wintertime, thermal energy will transfer from the warm house to the cold air outside. It's pretty simple. Find the warm object and make thermal energy go out of the warm object to the colder air outside. Third question. So during the winter time, thermal energy can quickly leave your warm house. So instead of turning on the heater, what can you do instead to keep the inside of your house warm? Well, I saw some really awesome answers and some great solutions from our students. So what can you do to slow down? So remember how in the previous slide the arrows were long because thermal energy was leaving quickly? Well, what can we do to slow down thermal energy from leaving the house? How can we make thermal energy leave the house at a slower speed, a slower rate? Well, something you can do is you can close the doors and the windows. That's what a lot of people said. Because when you close the doors and the windows, you will slow down thermal energy from leaving the house. Some people also wrote that they can put curtains on the windows, which is a really great idea. Curtains are insulators. They're going to slow it down. And they can also put on jackets and blankets. Or you can even cover your floor with a rug or a carpet. Those are great insulators. They will slow down thermal energy from leaving your house. All right, last question. In the summertime, the air outside is warm and the air inside the house is colder. So this time the air outside is warmer, it's 90 degrees. So how will thermal energy transfer in this case? Well, like we said, it always goes from hot to cold, from warm to cold. So if the outside is warmer, the arrow is going to go into the house because the house is colder. So thermal energy will transfer from the outside of the house to the inside of the house. So again, in the summertime, thermal energy will transfer from the warm air outside to the colder air inside the house. All right, now we're ready for our part 2 lesson. Now this is the part where you must listen and take some notes because your discussion question is all about these slides that I'm going to talk to you right now about. Okay, lesson part 2 is the role of mass. I will talk about what mass is. The question's going to ask, or it asks you, which container of water will require the most transfer of thermal energy into the water in order to heat it up to 120 degrees Fahrenheit. So there are 3 containers of water. There's a small pot, a medium-sized pot, and a large pool of hot water. So now, which container will require the most amount of thermal energy entering the water to heat up the water to 120 degrees? Well, let's think about it. Which one has the most mass? Mass is talking about how many particles there are. We'll say that this small pot of water has around 200 water particles. And then the medium-sized has about 600 water particles. And then this large pool has about 5,000 water particles. So clearly, this large pool has the most amount of water. It has the largest mass. And this small pot has the smallest mass. So which container will require more thermal energy to enter into the water in order to heat it up to 120 degrees? Well, remember, to heat up the water, every single particle in the water has to start to move and move and move and start to move faster with more kinetic energy. So if this one has 5,000 water particles, that means every single water particle must start to move faster. Each particle in this pool has to start to gain kinetic energy. So if you think about it, this small pot of water with only 200 water particles will not require as much thermal energy. Maybe the medium pot of water requires a little bit more, but then this large mass of water will require the most transfer of thermal energy in order to have every single particle move around faster. So again, the largest container of water will require more transfer of energy in order to heat it up to 120 degrees. All right, next type of question. Which container of water will require the most transfer of thermal energy out of the water in order to cool it down to 60 degrees? So same thing, we have a small pot, a medium pot, and a large pool of water. Now, in order to cool down the water, thermal energy must transfer out of the water. Thermal energy needs to leave the container of water. So again, the small pot has 200 water particles, the medium one has 600, and the large pool has 5,000 water particles. Now, if you want to cool something down, that means all of these fast-moving particles, every single fast-moving water particle needs to lose kinetic energy. Every single one of them. So if you have 5,000 water particles, all 5,000 of them have to start to move slower. And imagine how long that's going to take. It requires more thermal energy to leave this huge pool of water for it to cool down. So the small pot of water, it's going to require less thermal energy transfer out of it. The medium pot might require a little bit more. And then the largest pool of water is going to require the most amount of thermal energy to transfer out of the water so that it can cool down. So hopefully you're starting to see the relationship between mass and thermal energy transfer. Now here's a summary of the main points. We're almost done. Please keep watching because I'm going to go over the answer to today's homework very soon. So a summary. Objects or areas with more mass means more particles that each need to gain or lose kinetic energy. Remember, more mass means more particles. And that means that it takes longer to gain and lose thermal energy. The more particles you have, the longer it takes to gain thermal energy, and the longer it takes to lose all that thermal energy because there's so many particles. And that means more mass means that you can minimize or slow down the rate of thermal energy transfer. The more particles you have, the more mass you have, you are minimizing, you are slowing down the transfer of thermal energy. Now the opposite, objects or areas with less mass means less particles that each need to gain or lose kinetic energy. So less mass means less particles, and that means it takes less time to gain and lose thermal energy because there's just less particles in there. So less mass means that you're speeding up, you maximize the rate of thermal energy transfer. So the less particles there are, the faster thermal energy can transfer in and out of that object or area. So this part right here, this slide over here, you can use it to answer today's discussion question when you have to explain yourself. I have done the explanation for you, so make sure you take note of this or come back to this slide if you need. Now here is your discussion post. I will go over the question with you. It says, it is summertime, so it is hot outside. Thermal energy will enter the house and make your house hot too. So you want to minimize, you want to slow down the rate of thermal energy transfer into your house. You want to slow down how fast the heat enters your house. So what size house would help to minimize, would help to slow down the rate of thermal energy transfer into the house? And you must explain how you know using the notes from today's lesson. So here's your hint. A bigger house means more air particles floating in the house. A smaller house means less air particles floating in the house. So again, here's the question. Let me help you. I'm trying to help you with the answer, so listen carefully. So here are 3 different size houses, small, medium, large, and it's hot outside because it's the summertime. You don't want the heat to enter. You want it to enter slowly. So say that the small house has 500 air particles inside the house, the medium house has 1,000, and the large house has 5,000 air particles inside the house. So remember, bigger mass, more particles means it takes longer for something to heat up. So this small house that only has 500 air particles, it's like the small pot of water. Only a little bit of heat has to enter the house and your house will already start to be really hot. Now the medium-sized house, maybe a little bit more thermal energy needs to enter and you'll start to feel hot in the house. But for this larger house, so much thermal energy must enter before you feel like it's getting hot inside because there's so many particles in the house that each need to heat up. So I'm giving you the correct answer right now. I'm not going to say it explicitly, but you should know from what I just told you. So now you can go and comment on your discussion post And make sure you come back and see what my score for you was. Now the password for today's discussion post will be size, because we're talking about the size of houses. So please go to your class materials page, go on upcoming or go in the purple folder, press this, and you just have to copy the red sentence starters. So you can press copy and you can press paste. Number 1, the password from today's video is size. And then for number 2, just copy this. Let's try that again. Copy and then paste. And then the question says, what size house, small, medium, or large? So you're gonna pick the small size house, or it might be the medium size house, or the large size house. You should know the answer based on what I told you in the video. So decide and tell me which size and tell me how do you know, because, and then use the notes that I gave you to explain how you know that you're correct. All right, that's the end of our video today. Tomorrow is a break day, so you don't have any work from science tomorrow, so you can catch up on all your other work. But please turn this in by tonight if you're able to. All right, I will talk to you hopefully tomorrow in the Zoom meeting if you can make it.